What is it?
Radical 3 over 2.
Root 3 over 2 times, now sine of 45, root 2 over 2. Got it? All right, we need to put this together. Multiply these two together. Those are two fractions. You multiply straight across the top. So you get root 2 on top, and on the bottom you get 2 times 2. Remember, we're multiplying, not adding, right? So we're going to actually multiply the two denominators. So over 4. Plus over here, what do you get? Not 5, careful. Root 6. Root 6 over what? 4. Okay, and those have the same denominator now, right? And we're adding them. So you take root 2 and you add root 6. Don't tell me root 8. That's not root 8. That's root 2 plus root 6. We actually can't figure out what that is easily. That's your answer. Root 2 plus root 6, I don't know what it is, but I'd use a calculator to figure it out. Okay, understand? Now, I had to give you an angle. I had to give you an angle that you would be able to break down into two angles that you knew, right? If I gave you like 76 degrees, this wouldn't work, right? Because you're not going to be able to use two angles that you know. So this is only useful when you're doing this. It's only useful if this is a number that is somehow a multiple, adding multiples of angles that you're familiar with. All right, I have a question for you. If you believe this is true, what would this be? There's another example. What would sine of alpha plus alpha be, according to this formula? If I told you to take the same angle and add it together, well, you know what, maybe before I do that, wouldn't that be the same as doing sine of, what's alpha plus alpha? 2 alpha, right? Alpha plus alpha is 2 alpha. So if I asked you for sine of 2 alpha, wouldn't it be this? Yeah? And what would that be according to this formula? Aren't alpha and beta the same values? Aren't they the same? Okay, so use the formula here and just use alphas for everything. This would be sine alpha cosine what? Alpha plus cosine alpha times sine alpha. Yeah? Are these the same? Those are the same, aren't they? So you have two of them. You have 2 sine alpha times cosine alphas. And this is a new formula. I'm going to write it down. Sine of 2 alpha is equal to 2 sine alpha cosine alpha. That is, later on in the book they will talk about this. This is called the double angle identity. And this is used a lot in Cal 1 and Cal 2. We use this double angle identity a lot. So sine of twice an angle is twice sine of the angle times cosine of the angle. I'll give you an example of this one, all right? Do you have any questions? Just to show you it, I just want to show you that it works, okay? If I asked you right now, what is sine of 90 degrees? Can you all tell me without doing any work? It's the y-coordinate at where? 90, so what is it? 1, the answer should be 1, right? This answer should be 1. I want to verify that it's true using this formula. Do you all agree that I could rewrite this as sine of 2 times 45 degrees? Isn't 2 times 45 degrees equal to 90 degrees? So this formula is actually, that's my alpha right there. So I'm trying to do sine of 2 alpha. Sine of 2 alpha. According to this formula, it should be 2 sine of, what would it be for us here? sine of 45, and then cosine of 45 again. Okay, that's 2. What's sine of 45 degrees? Root 2 over 2, and then times cosine of 45 degrees. Root 2 over 2 again. Remember, this answer should be 1, right? When we're done, should be 1. Let's multiply across the top. These 3 multiplied together should be a what? Should be 4, right? These 2 together, what's root 2 and root 2? 2, and then that hit it with that 2, so you get 4 on top and on the bottom. 2 times 2 is 4, and that's 1. That's just to show you it works, okay? What's more important is that you remember that this formula exists, all right? Didn't we say sine of 90 was 1? That's just showing you that if you use the formula, we get the same answer, which should make us feel better about the formula. Okay. We have another formula. There's 3 more. What if you have sine, but this time it's alpha minus beta, not alpha plus beta? I have good news. It's the same formula I just gave you with a minus sign in between instead of a plus. That's all it is. So this would be sine alpha cosine beta, but now minus what? Cosine alpha sine beta. So the previous formula had a plus here, right? The name of this section is sum and difference identities. The previous one was sums, right? You had a sum inside of the trig function. Here you have a difference. And when you have a difference, here's how the formula changes. So using that idea, what would sine of 15 degrees be without a calculator? How could you do that? 45 minus 30, right, is 15 degrees. So again, I had to give you an angle that is not a common angle, right, but is the difference of 2 angles that you're familiar with. And now you have your alpha and beta, right? And then just use the formula. So this will be sine of 45 cosine of 30 minus cosine of 45 sine of 30. This is like just plug and chug, right? This is just plug and chug into the formula. Any questions? You liking this better than identity so far? Yes? Okay. Sine of 45, root 2 over 2. Cosine of 30, 1/2. Root 3 over 2. Root 3 over 2 minus cosine of 45. Root 2 over 2, sine of 30. 1/2. That's the one, right? It's the y coordinate at 30 degrees. You're going to multiply these two, and subtract. Multiplication comes before the subtraction. So what are these two together? You're multiplying. So root what? Root 6 over 4. Minus over here, root 2 over 4. Those already have the same denominator, so it becomes root 6, take away root 2, right? You are not allowed to put these together. These are not like radicals, right? So you can't actually put those together. That's it. That's our answer. Wow, he's low. All right, good? Now, you have 2 more formulas for cosine. So I'm going to give those to you, all right? if you have cosine of alpha plus beta, you're going to have one formula. And then if you have cosine of alpha minus beta, we have a different one. Now, of course, these can't be the same formulas we just had, right? They've got to be different in some way. So the big difference is that with the cosines, you're going to have cosine alpha, cosine beta. So in the first group, they're both cosines. You know, on the previous formula with sine and cosine? Here, they're both cosines. And then, do you see how this is a plus? On this formula, it's a minus here. Minus, and then it's sines. Sine alpha, sine beta. And then for the other one with subtraction, it's cosine alpha, cosine beta, exactly the same, but now plus, then sine alpha, sine beta. Yes?
On the last formula, I know that the one before that, it was titled double angle identity. What is the name for the other formula?
Okay, so this one right here, the way this appears, and this appears, and then the other ones that had sine of alpha plus beta, sine of alpha minus beta, those four are called the sum and difference formulas, okay? The one that I gave you that says sine of 2 alpha, that's called a double angle identity. That's the only one that's on its own. Right now it is. All right. So we have the same ideas here. I could ask you for some different values now, right? How about I ask you for this? Cosine of I'm trying to think of something that I want to give you here. I guess we don't need to make this complicated. Let's just do this. What's cosine of 15 degrees? So how do you want to do that? You want to do, you could do 45 minus 30, right? Could you do 60 minus 45?
Yeah.
You could do that as well. You just have to come up with two angles that somehow come together to be 15. So it's kind of your call here. So how do y'all want to do it? 45 and 30, 45 minus 30, or 60 minus 45? I heard 60 minus 45, so let's do that. You know what? If you want, you can do it with the 45 minus 30, and we should all get the same answer. We should. So this should be according to the formula. We're going to use the bottom one here, right? The difference formula, this one right here.
Yeah.
So it will be cosine what? 60, and then what? Cosine 45. Plus or minus? Plus, right? With cosines, it's the opposite of what you see there. So plus, and now we have sine 60, sine 45. What's cosine of 60?
1/2.
Good job. And then cosine of 45, root 2 over 2. And then plus, now sine 60, root 3 over 2. And then sine of 45, root 2 over 2. You multiply these together, you multiply these together, you add. So the first two together gives me root 2 over 4. Second two together gives me root 6 over 4. Add those together, I get root 2 plus root 6. Can't put those together because I'm adding over the common denominator of 4. One last one. Let's do cosine of 7 pi over 12. So when I give you the angle in degrees, most of the time students can figure out what two angles either add up or subtract to be that. Like 15 was 45 minus 30 or 60 minus 45, right? But 7 pi over 12, that's two angles that you know added or subtracted together, but I'm not going to tell you what they are. So how do you figure out what they are, right?
Well, can you subtract like pi over 6
From what?
from 7 pi over 12 and get what's left over?
Well, we're trying to figure out what two angles that we know add up to be this, or when you subtract them, you get this. Right? It has to be two angles that we already know, and then it becomes that. I think you're wanting to subtract something from this. Are you or no?
Yeah, so like if you subtract like, pi over 6 from 7 pi over 12, you'll get the leftover.
You'll get whatever's left over is what you add to pi over 6 to get that. I think this is what you're saying.
Yeah.
So you know pi over 6, right? You know pi over 6. You know everything about the trig functions at pi over 6. Yes?
Yeah.
And the fact that this is a 12 down here makes me think, okay, 12 is a multiple of 6, so maybe?
Yeah.
Yeah. I don't know, maybe I'm reading you wrong, but are you saying something like something plus pi over 6 is probably equal to 7 pi over 12?
Yes.
I think that's what you're saying.
Yes.
Like some angle, maybe, I don't know, I could be wrong, plus pi over 6 could be equal to this. So why don't we subtract pi over 6 on both sides, and that would give us the other angle.
Yes.
Does that make sense to everyone? Yes?
Does it matter where you put, so like if you put pi over 6 as alpha, it's like beta? Or would you have
I could do it for alpha or beta.
Or would you have to put like the lower number?
No, that doesn't matter.
Oh.
The order doesn't matter, just any two angles. I'm willing to go after that. I'm willing to try this. I mean, what's 7 pi over 12? Take away pi over 6. So if I want to subtract these, what do I have to do? Common denominator, right? So this is 7 pi over 12 minus 2 pi over 12, which is 5 pi over 12. Is that an angle you recognize?
No.
No, unfortunately it's not.
So let's
Good try.
pi over 3.
You want to try pi over 3? Pi over 3 and pi over 4. So if we try the same method for pi over, let's do pi over 3. Okay, so do y'all see that this doesn't work? Because that means that we would have to put a 5 pi over 12 here and add those together to get that. And unfortunately, 5 pi over 12 is not on our unit circle. So we could try again saying, hey, alpha plus the, let's try pi over 3 this time. Maybe that's equal to 7 pi over 12. And then you subtract 7 pi over 12 minus pi over 3, get a common denominator, 7 pi over 12 minus, multiply top and bottom by 4, you get 4 pi over 12. What's that?
Pi over 3.
3 pi over 12. Do you know what that is? Pi over 4. Do you know what that is? Yes? You do know this one.
It's 45 degrees.
45 degrees. Yeah, that's pi over 4. You with me? So I know that when you add this and this together, you get that. So I can rewrite this as cosine of pi over 4 plus pi over 3. And it does not matter what order I write these in. I could have done pi over 3 plus pi over 4. It's irrelevant. That's harder, right? It's harder when they give you the radians. It's harder to figure out the two angles. If they give you the degrees, you can like mess with those in your head easily. Well, relatively speaking. And now we go into the formula, right? So this should be according to the formula cosine pi over 4 times cosine of pi over 3 minus, right, because this the formula, right, has a minus there, sine of pi over 4 sine of pi over 3. And we know those, right? Cosine pi over 4 is root 2 over 2. Cosine of pi over 3, half. Pi over 3, 60 degrees. Cosine, x coordinate. Minus sine of pi over 4, root 2 over 2. Sine of pi over 3 is the root 3 over 2. So this is root 2 minus root 6 over 4. I'm just skipping ahead because we've done a few of these now. Hey, we got a negative answer, didn't we? Isn't that a negative answer? Root 2, take away root 6. That's a negative number on top, and the bottom is 4. So our answer is negative. The only reason I'm bringing that up, because remember that whole thing, all students take calculus. Do you remember that? Like this told you where the trig functions were positive and negative. If I get a negative answer for cosine, right? This is cosine. If I get a negative answer, I'm either in the what? Second quadrant or
Fourth, third.
third? I'm either here or here. Right? I'm either here or here. Well, 7 over 12. If you do that as a decimal, 7 over 12, that's a little bit less than 0.5, like it's, what's this angle right there? What's that angle? Pi, right? Pi. 7 divided by 12 is smaller than pi. I mean, smaller than 1, right? Smaller than 1. So we shouldn't be quite that far. So we should probably be somewhere in here. So I'm just saying we should expect a negative answer because this angle 7 pi over 12 is in the second quadrant. All right. Continuing, we have 10 minutes.
So when we solve for these, are we only solving for the answer, or do you also want us to put what quadrant?
Oh, no, I'm not asking for quadrant. No.
No, so the question.
Yes.
Are all of them basically be kind of the same, like root 2 and root 6?
Yeah, because these are angles you're going to have to know already, right? So a lot of these answers are going to look the same. Because they're going to be things, they got to be based off of angles that you're familiar with. Everything here seems pretty straightforward so far, yes?
Yes.
Okay. How about this? I'll give you one of these. What if I wrote sine of 80 degrees times cosine of 20 degrees minus cosine of 80 degrees times sine of 20 degrees, and I asked you what this is without your calculator. Do you recognize that pattern that I have here? It's like sine of something, cosine of something, minus cosine of something, sine of something. What is that? What formula is that?
It's sine of 80 minus 1.
Yeah, this right here, we're using the formula for sine of which one?
80 minus 1.
Alpha, is it plus or minus? It's the minus beta, right? Because there's a minus between them. Isn't that really the sine alpha minus beta formula? Where here alpha is what for us? 80, and beta is 20. So this is really equal to sine of 80 minus 20, but 80 minus 20 is 60 degrees, right? And do you know what sine of 60 degrees is?
Radical 3
Yes.
over 2.
Root 3 over 2. Now this problem doesn't come up much because the chance that you're going to be given this is very low. But it's a good exercise to see, do you recognize this as being the formula for sine of the difference of angles? Do you recognize it? And then you can see how even though we know nothing about sine of 80, right? We know nothing about that angle. It's not one of our common angles. We know nothing about 20, but the two of them together, right, give you a 60. So, all right, last problem, then we'll call it a day. Call it a week, right? Thank you. You too. Right? If sine of alpha is equal to 4/5, and I tell you that pi over 2 is less than alpha is less than pi, just hang tight, all right? This is going to look terrible. And I tell you, and sine of beta equals -2 divided by root 5 with beta bigger than pi but less than 3 pi over 2. I want us to find what is sine of alpha minus beta. Let's put a star next to this because this is definitely a test type problem, all right? All right, I'm giving you some information about sine of alpha, right? I'm telling you what sine of alpha is. And then I'm telling you some information about what? Beta, right? Sine of beta. These are two different angles, alpha and beta, right? Two different angles. I'm giving you sine of alpha and I'm giving you sine of beta. I'm telling you what the values of those, the value of sine is at those two angles. And from that, I want you to tell me what sine of alpha take away beta would be. Okay? So let's just first go to the formula. What's the formula for sine of alpha minus beta? This is sine alpha cosine beta minus cosine alpha times, careful, sine beta, right? That's just the formula, right? Now, do we know any of this? Do we know what sine of alpha is? Yeah, we already given this, right? So I'm going to put here this, check. I know what that is, right? Do you know what cosine of beta is? No. Okay, so I don't know what that is. Do I know what cosine of alpha is? No, I only know what sine of alpha is, right? So I don't know this. Do I know what sine of beta is? -2 over root 5, so I know that, right? So look, when you look at this formula, in order for me to answer this question, I just need to figure out what cosine of beta is and what cosine of alpha is, right? If I could figure out what those two things are, I could just fill in the formula and I would have an answer. Agreed? So let me go after, what do you want to go after? Let's go after the alpha first because that's the angle over here, all right? I want to find right now, this is work I'm going to do on the side here. I want to know what cosine of alpha is, right? I want to know what this is. And all I know is that sine of alpha is 4/5 and that alpha is in this quadrant. So let me draw a picture. Alpha is between pi over 2 and pi. So alpha is in the second quadrant, right? So I know alpha is, the angle alpha is somewhere over there, right? Now, sine, by definition, is which coordinate over which coordinate? Y over r, right? So this is y over r. This is my y coordinate over my radius. So if I draw what alpha angle, the angle alpha looks like over here, I know that the y coordinate is 4, right? And I know that the radius here, the distance from here to here is 5, right? From here to here. To figure out what cosine of alpha is, I would need what over what? X over r. Good, right? This means I need to know what x over r is here. I need x, right? I need to figure out what x is. Pythagorean, exactly. Now we're going to use Pythagorean. You with me, everyone?
Yeah.
So I'm just going to imagine a little triangle in here. And I have, this is 5. The y coordinate is 4, right? And the x coordinate is this. Now, I can solve for x here, can't I? Yes? And when I get this answer, I'm going to get a plus or minus, right? I'm going to do x squared plus 4 squared equals 5 squared. This is x squared plus 16 equals 25. X squared equals 9. And x equals plus or minus the square root of 9, which is x is plus or minus 3, right? Did I go too fast? Move things around, square root, yeah? Now, is it plus or minus? Minus, why? Because we're in the second quadrant, right? We're in the second quadrant. So that means that cosine of alpha, which is the x divided by the r, is what? Negative, right? This is negative 3. Negative 3 over 5. Now I know what that is, right? I need cosine beta now. So I'm going to play the same game with a different angle, right? This is a different angle, so I need a different picture. I need to figure out where I am. I need to figure out the x and y coordinates and all that stuff, right? I'm almost out of time. I have like a minute. So here I want to find what? Cosine of beta, which should be the y over the r, right? The y over the r, the y, no, x over r. What am I saying? X over r, right? This should be the x coordinate divided by the r. But I'm given, we're talking about beta right now, right? We're given sine of beta. We're given that it's negative, and we're given that we're in between pi and 3 pi over 2. So we're given that we're somewhere over here, right? And sine, by definition, is the y over the r, right? So I'm going to look at the y as being negative 2 and the r as being root 5. Does this look familiar? Do y'all remember when we've done this, right? This is not the first time we've done this. It's just been a little while. So I can say here that this point has an x coordinate, which I don't know yet, and a y coordinate of negative 2, and the radius, which is this distance from here to square root of 5. And then I draw a right triangle again. And it really doesn't matter how you draw it. I'm going to draw mine upside down because we're down in that quadrant. This is root 5. The x coordinate I don't know, but the y coordinate is negative 2. Now, I don't need to put negative here. It's a distance. It's not going to matter in Pythagorean because I'm going to square it, so it's not going to have any impact. So I do x squared plus negative 2 squared equals root